Hi everyone. Today we'll cover human annotator for data leveling. So we know that in artificial intelligence, in machine learning, uh, we have mostly we need data annotations to data leveling. I mean, mainly for the supervised learning. And so far, most of the cases, we do these kind of things for different applications based on human involvement, human annotator or human data leveler. So the ground truth, the original data, what is the thing, is provided by the help of human beings. So let's see some of the things in this lecture. All right, so we know that data in AI are categorized as level data and unleveled data. So normally the raw data is unleveled, no leveling. We don't know what is it. So if I draw this and tell you that what is it, and I don't know, nobody knows. But say I give a name that this is AAA. So it means that this is a data. I don't know what is it, but we know that this is AAA. And say this is another one, and I say this is BBB. So this kind of data leveling. Of course, we don't do this kind of, stupid, weird way for something. Let's see some of the examples. So data that has been assigned specific categories or tags or levels or classes. So then we say that this is this. So for example, spam email or not spam email. So if we can say that, okay, based on these categories, these emails are spam category and these are not, so the machine learning model will be trained and based on this it will work. Say customer feedback, like positive, neutral, or negative. So sentiment analysis. So we say sometimes in airports or somewhere, we have toilets and there are three buttons, negative, neutral, or positive. So if you like the toilet, it's very clean, then you put positive. Of course, so we try to support that stuff. And neutral, sometimes negative if it's dirty or not good. So similarly, different customer feedback level. So when we do like this way, so then, for that product, the rate, it goes like this way. Another one, we know that movie reviews, or if we buy anything from any website, then there are stars, like 1 to 5 star. Okay. So if say 5 star is perfect, 3 star is still considered good, rest of the things terrible, and so on. Okay. This is very, very bad. Okay. So you see that different kinds of ratings. So what happens that those ratings are referring the product. So we give them some tag or levels or specific categories. Now look at it. So if you are from America or US or another country, you will find that it looks a bit different, isn't it? Can human or AI, for example, a autonomous robot or autonomous vehicle that can automatically understand something. So in a new situation, unless we train them, is it easy? Like if you visit a new country and to understand the traffic signals and rules regulations, like this is what? In Japan, for example, this means stop. Okay, so that's the point. I know the meaning, and this is the so on. So the point is that the train AI or human. So if you train me as a driver, then I know. That's why when we move to a new country, we need to understand different rules and regulations for the traffic rules. Without training, if you start driving, and most likely you start getting, tickets. Okay, so for example, in UK or London, we have 6 second box. Like you have yellow marks, and if your car is there stopping for 6 seconds, you are welcomed by a letter to pay 130 pound for that things. Of course, if you pay early, it's a 50% discount of the punishment. So you see that there are different rules and regulations. Level the data for training. So that's another point. So we need to level them, we need to train. So human or AI. So let's see a basic AI workflow process where a data set is leveled. So this is an unleveled raw data. There are experts or non-experts, sometimes for cheap works or something. We engage average people to do the things without any expertise on that, and they level. So the leveling team levels. So definitely we need more people. If one person is doing, and if the person is not educated of that topic, or not sincere, or lazy, okay, and so on, so then probably the output, the leveling will be very poor, or even bias, but and vice versa. So that's why we need multiple levelings, three, four, five. I mean, it's less to judge something. But next one is that when we have the level data, so we know that instead of unknown raw data, we say that, oh, this is this is another one, this is another one, and so on. Then we train the AI model and prepare it so that we can use it in real life situation later on. Now, let's see an example of an annotation. This is really surprising. I mean, we know that in image processing, or in a modern AI era, I mean, 100,000 images, this data set is nothing, right? You know that MRI scan, or CT scan image, or X-ray, or others. Standard good data set means millions of images. But let's say zero point 0.1 million images only. And I want that only one leveler will level it. So say this is me. Atik will do the leveling, and say one image, because this is, say, it's an MRI image, to identify uh, the tumor in that, and then it takes, say, 10 minutes per image. Okay, so if you have this amount of images for 10 minutes, oh my God, huge amount of, so in terms of hours, I mean, a huge amount of hours. If we say 8 working hours per day, no lunch break, you see, and 8 working hours per day, and still it covers 2000 plus days per, I mean, for this amount of data for one person. So 1 month we get 21 working days, isn't it? More or less. Okay, then how many months we have? On almost 100 months. It means that over 8 years for a person just to do, I mean, 10,000 100,000 images. If an image takes, I mean, 10 minutes to annotate, some people say, oh, it's easy. It's not actually. At Osaka University we had, I mean, over 30 staffs doing different kinds of image annotations, and it's a laborious job, and of course costly. We needed to pay, and then they have been doing this for full-time job or part-time, like, I mean, 1 month, no, 1 year probably, yes, and then they have been working on years after years for different kinds of annotations. So we need three or more annotators in real life for all images to avoid bias or error. Now, you think about it, that, I mean, for how many years? And if you want to consider that, oh no, if within 8 years for data annotation, by this time AI will be developed much more. So what to do? So we need to try to finish it in 1 year, but we need more annotators, more money, and of course, all the images will not be annotated by one person. So maybe there are 50 persons or 25 persons, and we say that, okay, that first 20% of the images, or 10% of the images, okay, will be handled by 5 levelers, and next one, something like this, to cover in 1 year. So these kind of things, you can understand that how much difficulties are there for human annotation. But without human annotation, how can we do that? We will have a lecture later on automated annotations. But again, see that for good AI too, because if your training is not good, if your training is poor, then your I mean, outcome will be very bad. Yes, I mean, if human beings, our family background or neighborhood or personalities, or, I mean, disturbed family or something, if we have a bad I mean, training in life, but it's still human, we have lots of good points, we can be an excellent person even if our background was poor, and vice versa. So, like, I mean, Quincy Jones, you know that, I mean, he just died yesterday or day before yesterday, 91 years old. I mean, the most one of the most famous, I mean, persons. Now, in music, of course. Now he's I mean his parents and his neighborhood was with gangs and mafia guns and other things, so he could be in a bad direction, but he went to another direction and so on. So you see that human has enormous abilities. But what about AI? Can we provide AI random data and still it can do? We'll go through this process. It's not easy so far. So challenges for manual, crowdsourced, or expert labeling. So in previous lecture, we mentioned that manual labeling or crowdsourced labeling or expert labeling, what are the challenges? Of course, time consuming, we noticed, very costly because you have to pay, all right? And this is really difficult. So what are the solutions? We need to go for automated labeling to make it more efficient and scalable. And there are different things, including active learning and so on. Now, who can label these MRI images for brain tumor to prepare to train AI? Okay, definitely. So far, we are doing by human, not human radiologist. If you ask me to determine, maybe I'll say, oh, it's a bit white. So this is a tumor, or is it tumor? Which one is tumor? And what kind of tumor? So definitely we need the expert. And labeling for radiology images, usually we need, professional radiologist, human radiologist, to manually draw or identify that this is the thing. But if you say this is the thing, no, you have to exactly pinpoint, what are the dot and so on, okay, to shape into an image. And we mention that attaching a word, so we say that this is this kind of tumor, or and so on. So this is another example, like instead of classification, we can detect as a blocks, or exactly we do it, or different ways. So there are different ways of labeling. I just provide some of the examples. Now, say classification. The entire image is associated to a category or class or type or pattern. So that's why we mention pattern recognition, which is like classification, class identification, type identification, category recognition, and so on. So say this image, we just said that the entire image is a tumor image. Okay, so it means that this is a tumor. This is a broadly classification. But what about if we can detect a part or parts of the image and mark it with this rectangle, so that we can associate to a category or class or type or pattern? Another way is the better way, that instant segmentation, like part or parts of the image are marked by a polygonal boundary, or we in image processing we say that a region of interest. So ROI, it's not the business term. If you are from business background, we know that return on investment probably. So which is then associated to a category. So I learned return on investment recently, because we are working with a fintech company for research collaboration. So then I learned this term. So if there are multiple instances distributed in the image of a single category, then we mark them separately and distinguish them. So for example, this is, say, we say that there is another kind of tumor, or there is a small tumor, or there is another tumor and this is another one. So it means that in multiple areas we are marking them. And semantic segmentation is another one, like all parts of the image are marked by polygonal boundaries, which are then associated to a category. So there are different ways we can do. It depends on the AI algorithm you want to produce and develop and so on. All right. So expert to annotate or label images for ground truth. So in this case, exactly where the uh, mm, tumors are, that is called ground truth data. That is the ground truth. So when you train, the machine learning model will understand that these areas, these are, tumor areas, others are not. And after the training, when we test with a new thing, it can originally locate where was the tumors and where was not. and how accurate they are. Based on this, we can find true positive, true negative, false positive, false negative, this kind of stuff, the confusion matrix that we know, and so on. Okay, so labeling typically involves a human expert clicking, click, 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 click through various options, or maybe you can draw like this kind of polygons, and then say like this way, should select category, and most cases manually drawing on the top of the image, and the drawing must be accurate. But we cannot uh, get accuracy if we don't give time, because in life, just like any student, if they don't study, they forget, and then in the exam they will struggle. In real life, they will not get a good job because they don't connect knowledge from one to another. They just read something little bit what teachers cover, and they don't become a knowledgeable person. So it means that I mean, time is very, very important. And when the time is important, when you are young and you have a spirit, and then you give more time to education and learning, that will help you better. When we grow up, we have lots of other family issues, and energy also not so much. So this is another point. But unfortunately, or fortunately for teachers, we have to study always and keep learning and so on. So the back to the point that, I mean, drawing must be accurate, but for accurate drawing, we need to give more time. All right, so that, I mean, it becomes better and better. Now, providing an image with segmentation leveling can easily require maybe 2 minutes, 10 minutes. Of course, 2 minutes is too, I mean, naive concept. Roughly 5, 10, 15 minutes, it depends for simple cases. And if it's longer, like, I mean, lots of, I mean, the tumors are distributed for MRI image case, or another one, or single person versus multiple people in the scene. So if you have a surveillance camera, and in the camera you have, say, one person is walking, so you can easily track and annotate. But if there are 10 people walking and overlapping, then it's not easy. So need longer time, and it more complex, and per image per person. To avoid human bias and error, so each image is typically labeled by several human, minimum case, say that 3. So that is a good thing. But it depends on the field as well. For radiological cases, the leveler must be trained radiologist, and definitely it's costly. And if you engage them, who will work with their patients? So sometimes if you have less money or not enough, maybe not serious cases, you can engage, I mean, students, but it depends. So what we have seen and noticed that when we have data sets which are typically large, this kind of task, manual annotation, and sometimes we cannot avoid manual annotations, and it's repetitive, time consuming. Repetitive means boring. The person doing everything, like always looking at an image, and then dot, 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 and put like this. How long can you do that? It's really boring work, without a doubt. Error prone and expensive as well. Now, are there any free tools to do that? So, but there are few. So, for example, I just a note here. If you want to do explore, there are lots of information in the websites. So, free one is Medical Imaging Interaction Toolkit. So you can click it or search it, or you can enjoy this YouTube video, so that you can see. Now, have a look based on this, that leveling, annotating, or showing ground truth of tumor in images based on the previous link. You can say that, say this is so in this software, you can open an image. So this is the image. Now you can check the image, rotate, and then finally at some point you find, oh, there is a tumor, looks like tumor. Okay, and you expert, you can notice that there is a tumor, and then you I mean, locate it. Then you can see again that, I mean, the tumor border is here. You see that if I circle it like this way, I miss this part, isn't it, right? So you have to end missing this part. So very carefully should be done, and it should be enlarged and so on. So okay. And when you see, you can mark it, and then say given color, so that it becomes understandable later on. So then you should move the image like in another direction, and you see that this is like this way, and you mark it. And then another the same person, same kind of problems, I mean, image sequences, and you find that in another direction the MRI image looks like this way, and so on. And so then you find another tumor, for example, in another location. So when you cover every everything in the same block. You see that there is that one, there is another one, but of course not good quality and so on. So what we see here that, I mean, this is a one sort of annotations, but there are different kinds of annotator, I mean, task and for annotations. Now let's see another example. Okay, this is gait. We know that gait means walking patterns. Okay, this person is walking, and we will see that, I mean, from this it looks like normal walking, and it's look like very hurriedly walking, isn't it? Or do you think that it's a younger person or elder person? To me it looks like someone, I don't know. I really don't know. So different annotations, annotators will have different perspectives. So you can say that, oh, the person is walking faster, but this is vertical line, so very young guy, and it looks like very fast, and I don't know what it is. What about this one? Is it slower one? And is it a good? And what about this one? You see that if you put a vertical line, okay, and it seems like that the person is little bit imbalanced, the walking pattern is towards this direction, so it means that it's different, but some people will say that no, this is fine. So the attributes, the properties or classes are varied based on different annotators. And if you look here, I mean, you see that, I mean, how they walk. Okay, looks like Tom and Jerry type walking, and I don't know what the heaven or hell he is doing, and so on. All right. So yeah, we have another, I mean, important work we published here. If you are interested, you can read it. But the goal is that gate relative or comparative attributes. So when multiple human annotations are done, say 5 students annotated, differentiated this, they might be confused. They might not understand the perception of it properly, like individual sense or preference, just like, I mean, which walking pattern is good, handsome, good looking, okay, or not. So, and it may affect the performance of algorithms because if you have imperfect labeling. Now have a look, the subject A and subject B, all right, and their working patterns are given here, and we gave the annotators for this work. We told the annotators, okay, look at those and tell that subject A is left is better, then you score like this way, or right is better. If they are similar, you put the similar thing. So is it beautiful walking, graceful, or cheerful, imposing, relaxed, this kind of things. So left is better, right is better. That's the point, or similar. So definitely we notice that among the annotators who were paid students, did the thing, they could not perform very well always, because it's normal human subjective perception or understanding that whether it's beautiful or graceful or cheerful, just looking at the silhouette. If you see the human, okay, or the cat, then by looking at the person you can like it or not, okay, but looking at only the silhouette image or background or no background or something, it's very difficult to understand and so on. All right, now annotator, we see that uncertainty issues are there. Now, how much uncertainty? How to know? So annotators may not have the absolute confidence when they, I mean, put any class or attributes, like whether, I mean, it's a goodness or cool or relax, arm swing, walking speed, this kind of stuff. All right. So we developed two kinds of data sets. So one is 7-grade data set having 1,200 subject pairs. Okay, and we gave them side views as well as front views. So this is the front views and these are the side views, and say assign 5 gait attributes like beautiful or cheerful, imposing, relaxed, graceful. This is just to give you an example. There are thousands of different examples for other cases, and we wanted to, I mean, this is a method. We are not going to the method, but I'm showing that how, I mean, this kind of annotator based uncertainties are involved and it impacts. So there are a few more things. If you are willing to, you can just have a look. But another one also, that 3-grade, like where there are 3-grade. 3-grade means, as you can say that -1, 0, and +1, for example, even though I read it reversely. So it can be from their different attributes, like relaxed versus nervous, happy versus sad. So can you understand that from an image, walking pattern, without looking at the face? Because for privacy, you do not have the facial images. You cannot see my face, but you can see the walking pattern. So this is a research as well, and we need data, and we need to annotate those data based on this, and to see that whether the walking is happy or sad walking, nervous or relaxed walking, or step length or arm swing, these kind of things. Okay, these are research. So research is not so easy. We have to work hard and so on. So far what we have seen, that human annotation is challenging. There are bias and error issues. Cost and time is extremely important to consider for large data set, and that's why we need to plan for automated data labeling, and we have some methods. We'll go for it, and that's why we need to work a lot. So today's world is better because we have millions of committed efforts globally. Okay, since long. Let's keep learning. Don't be lazy. Let's try to contribute and try to push the boundaries of AI. Together, we can build a better world where AI is a force for good and, of course, for food. I love food, but no food at this moment. So that's it. So enjoy, and hopefully, we can move to the next lecture, which is related to automated data labeling or annotations. Thank you very much indeed.